Hello everyone and welcome back to another video about IB Math. In today's lesson we will be studying integration by part, which is a super important integration technique that's used in the IB Math AA high level. So what is integration by parts and how do we apply it correctly, and also how do we assume the u and the dv over dx substitution correctly? We will learn that in today's lesson. First, we use integration by parts mainly when we have multiplications between two different functions, like an algebraic function x or x squared multiplied by trigonometric or exponential function like sine, cosine, or e to the x, e to the negative x, and e to the, like for example, 7x, and so on. Also, when we have a multiplication between an algebraic function and logarithmic or inverse trigonometric like arcsine or arccosine. So here, this is the integration by parts formula which is given in the IB Math booklet. As you see, first we assume the u substitution. So here, for example, u could be x. And the other one here would be dv over dx. So here, sine x would be dv over dx. And then, after we assume the u substitution, we find du over dx by differentiating. And also, after we assuming dv over dx, we integrate it to find v. Because we need to replace all of these in this formula as you see here. And also, we have to be careful that not every time the first product here will be u. We have some certain rules that we'll explain later about which one to be assumed u and which one dv over dx. Let's now clarify everything with few examples. Here we have the integral of x multiplied by cosine x. So as we said, we will assume here u to be x here. So u now is equal to x. And therefore, to find du over dx, we differentiate, so the derivative of x will be 1. Then, the second product here, which is cosine x, will be assumed to be dv over dx. Therefore, when we integrate cosine x, as we know from the formula booklet, v will be sine x. After that, we will replace these in the integral using this formula. As you see here, first we have u multiplied by v. So we will multiply u, which is x, by v, which is sine x. So we will have here u times v. Then we have minus from the formula the integral of v times du over dx. So here we have v, which is sine, times du over dx, which is 1. So true, now we still have an integral, but it's very simple where it's available easily in the formula booklet. As we know, when we integrate sine x, it will be negative cosine x. So here, the same answer can be written like this. The integration of sine will be negative cosine x plus the constant of integration c. Here we have two negatives and that will be plus. So the final answer will be x sine x plus cosine x plus c. This is now the answer to this integral. But now we have to be careful about which one to assume u and which one dv over dx. Here I didn't assume u to be x just because it appears first and you have it here first in the formula. No, we have certain rules, which one is u and which one is dv over dx. In the same example here, if we do the opposite by assuming cosine to be u and dv over dx to be x, then here it will be wrong and we will not reach an answer. Check now here. If we assume u to be cosine, then du will be negative sine. And dv over dx is x, therefore by integrating v will be x squared divided by 2. If you replace in the formula above u multiplied by v, which is here x squared over 2 times cosine, minus v times du over dx, which will be this. Here we have even an integral that's a lot harder than the original integral here. Here we have x times cosine x, but here we have x squared times sine x, and that's a lot harder. So that's why we cannot continue here if we assume this. So how do we assume correctly? Generally, when you have an algebraic function here, like x or x squared, multiplied by sine or cosine, or even e to the x, we assume the algebraic function to be u, and sine or cosine or any form of e to the x would be dv over dx. Now, but if you have ln x or inverse trigonometric like arcsine or arccosine, in that case we assume u to be ln x, and then we find du over dx, and we assume here u to be the inverse of trigonometric function, but dv over dx will be the algebraic part. Otherwise, if we don't do the same substitution here, we cannot continue. Now notice that also in some examples you would see the integral of only ln x. So here we can do this also by parts, integration by parts. But you might say we don't have another function or another product. Here we do. You can assume that this is 1 times ln x. So to do this by integration by parts, we assume u to be ln x as we said, and therefore du over dx would be the derivative of ln x, which will be 1 over x. Now dv over dx will be the other one, so here dv over dx will be x, it will be 1, so when we integrate it, it will be x. We replace now in the formula, so the integration of ln x will be, here as you see, we have u multiplied by v, which is ln x times v, which is x, so here x times ln x, minus the integral of v multiplied by du over dx, v here, which is x, times du over dx, which is 1 over x as we see. So cancel here x and x, so it will be x multiplied by ln x minus, here we have only the integral of 1, and that will be just x. So this is the final answer to the integral of ln x times 1, which is basically just ln x. Here now we have another example. We have x multiplied by ln x. As we said first, we assume u to be ln x, and therefore the derivative of ln x will be 1 over x. dv over dx will be the algebraic part, so when we integrate to find v, it will be x squared divided by 2. We replace now in the formula here, we have u times v. So u here, which is ln x, times v, which is x squared over 2. So as you see here, u times v, minus the integral of v, which is x squared over 2, times du over dx, which is 1 over x. Here now, we can simplify this. When we simplify x squared over 2 times 1 over x, here we can just have x divided by 2. We have x squared divided by x, which is x. So integrating this will be easy. We just increase the power of x by 1 and divide by that power. It will be x power of 2 divided by 2. But since you have another 2 here, it will be 2 times 2, 4. So it will be x squared over 4 when we integrate this, plus constant of integration c. I hope that you have enjoyed the video. Please consider subscribing, and thank you for watching.